No. That's not what I said.
We were talking the last couple of days about how we can graph certain functions, certain quadratic functions. They were of this form here. That one and that one. Okay? Where those, the vertex is always on the y-axis. Okay? And the y-axis is always the axis of symmetry. Now, if we start adding other things, okay, so this c was just a constant number. So this might be like 2x squared plus 3. Okay, that's still a parabola on the, with the vertex on the y-axis at 0, 3. It's going to open upwards, it'll be concave up. So that's great, that's awesome. That is something that we've been working on. Okay, but if I put an x on that 3 now, that completely changes the game on what this graph does. Okay, the vertex will no longer be at 0, 0. Or that one was 0, 3. It will no longer be there. Okay, it's going to be somewhere else. It's going to be at a different ordered pair. And what I want to show you today is how we identify where the vertex goes based on things like this. And what we learned today will actually even allow us to locate the vertex in these that we've already done using today's knowledge. Does that make sense? So today's information will allow us to find the vertex of any quadratic function, ones that we have not seen and even the ones that we have seen. Okay? All right, so it says in the previous section we analyzed those two functions. I discussed how the graphs of those are similar, yet the c value moved the graph up or down. Okay? Now we want to discuss the quadratic of this form. Y equals ax squared plus bx plus c. So a specific one might look like 2x squared plus 3x, maybe plus 5. Okay? And we're going to try to decipher what do all of these numbers here do to that original graph y equals x squared. Okay? Okay, so ultimately what we find out is that this b term, okay, the term that has the x with it, x to the first, that is going to move your graph left and right. So the c term moves it up and down, the b term moves it left and right. Bless you. Okay? If we look at this one, okay, this b term right there is directly related to that number right there. Okay, and we'll talk about how we find that in a moment. Okay, this b term is directly related to that ordered pair, or that x value out of that ordered pair right there. And then this b value is directly related to that one. Okay, but we're seeing that when you add like 2x, add 4x, add 6x, it starts moving it left, and it's also moving it down, correct? Does that make sense? So this term is creating more lateral and vertical movement together from that original x squared. All right? All right. If we look at this, it says, notice each line of symmetry is located at the x-coordinate of the vertex, but it's located at this formula right here. If you take the opposite of b and divide it by 2a, the opposite of b and divide it by 2a. So let's try this in these examples. Okay, if 2 is my b value, okay, I'm going to take the opposite of that, so negative 2. And then divide that by 2 of those, 2a. Okay, so that was b, the opposite of b, and that was 2a. What do I get if I divide negative 2 by 4? What's that reduce to? Does it become negative 1/2? Is that x value right there? Does that make sense? Okay. If I go to the next one, if they say x is the opposite of b over 2a. If my b is 4, what is the opposite of that? opposite of 4. And then 2a would be 2 times 2. So does that reduce to negative 1? Negative 4 over 4, is that negative 1? Is that exactly the same as that x coordinate of the vertex there? That makes sense? Okay. So now let's go to this next one. X is equal to the opposite of b over 2a. So b is 6, so the opposite of that is negative 6, over 2a's, so 2a would be 4 in this case. That gives me negative 3 over 2, which is the same thing as negative 1.5, which is that highlighted value there on that x value. Okay? So my hope is, that you're seeing here, is that the axis of symmetry for any parabola is found by taking x equals the opposite of b over 2a. And not only does that give you the x, or the axis of symmetry, it gives you the x coordinate of the vertex. It gives you x coordinate of the vertex. Now, I want to show you this one other thing. Okay? If this is the x coordinate of my vertex, that's a value, an x value, that shows up on my graph. Well, if I know that the graph was constructed by y equals 2x squared plus 2x, and now we know that the x value is negative 1/2, if I plug that negative 1/2 into the rule here and evaluate, okay, so negative 1/2 squared is 1/4. 1/4 times 2 is 1/2. And then plus, this is going to give me negative 1. So what's 1/2 plus negative 1? Negative 1/2. So now it tells me my y is negative 1/2. And that's what we're seeing right there. So if I want to find my vertex of any quadratic, opposite of b over 2a gives me the x value. And I plug that x value in to get the y value. My hope, now obviously you don't have your computers right now to use Desmos. Okay? You got your phones. My hope is that you would take 2x squared plus 2x. And then let x equal negative 1/2, and you get it to evaluate what the y value is. Does that make sense? Okay. If we go back to, let's do this middle one, which was 2x squared plus 4x. Okay. We had the opposite of b over 2a. We said the opposite of b over 2a ended up being negative 1. So I'm going to evaluate that at negative 1, and I get negative 2. As my y value. So if negative 2 is my y value, look at this ordered pair. When x was negative 1, you were paired with a y value of negative 2. So this is a procedure that is always going to allow you to find the location of your vertex, no matter what. Is that okay? All right. So tips for graphing quadratic functions. As we graph these, the number one thing you're going to do, so this is even going to work for the ones that we've already done. Okay? You're going to find x equals the opposite of b over 2a. You're going to find that axis of symmetry. Okay? Says step 2 says use that above x coordinate and plug it into the original function to find the y value. Use a calculator to do that. Okay? That's going to be the same thing. A lot of times that opposite of b over 2a is going to be a fraction. So a lot of places we can make mistakes. So that point when you do that is the vertex. Step 3 then says now substitute x equals 0 into the function. This will always lead to y equals your constant value. Okay, and it's going to give you your y-intercept. Now that we have our y-intercept, we graph that. And the idea then is once you have your vertex and your line of symmetry, you have your y-intercept, which is going to be on one side of your line of symmetry. You can use your line of symmetry to find, with that y-intercept, to find a point that is on the other side. So it'll give you a third point. And that's what that part 4 is saying. And then once you have those 3 points, connect them with a smooth curve, and you've got your parabola. Okay? Now that's not the only thing, the only way to graph them, but it's a useful technique. So we're going to approach this question using that set of 5 steps. Okay? So it says y equals x squared minus 6x plus 4. I think it's a good idea because it's going to be something that we need to do later on in other content areas. Is label or identify what A, B, and C are for your quadratic. Remember, every quadratic is y equals some A times x squared plus B times x plus C. A is your coefficient for x squared. What's the coefficient right now for x squared? If it's not written out there, it's a... Is it a 1? Does that make sense? Okay. What's your coefficient for B? B is the number in front of just the x to the first. We see B would be -6. And then C is going to be 4. Okay? Essentially just recognizing the numbers in front of the variables, and the C is always that last number. Okay? Now, once you do that, you got to make sure that you take the signs that go with them as well. Okay? So B has to be -6, not just 6. But now if I want to go through those steps, the first step said find x equals the opposite of B over 2a. Well, if I've already identified what A, B, and C are, that's pretty easy. What is the opposite of -6? It's the opposite of -6. No, what's the opposite of -6? 6. Over 2a, a is 1, so 2 times 1. So what is 6 divided by 2? 3. Okay? So that is the x-coordinate of my vertex. That is also, if I say x equals 3, that is the equation of the line that is the vertical, is the axis of symmetry. And it's a vertical line in this case. Okay, so we're good there, right? Now, we want to find the y value that goes with that. So then all you're going to do is just say, okay, y equals, and I'm going to rewrite x squared minus 6x plus 4, but wherever I see an x, we're going to use that 3. So I'm going to type in, so it's going to be x squared, so 3 squared, minus then 6 times x, which is 3, and then plus the 4. Now, like I said, you can use your calculator, but I'm just going to do this by hand. 9 minus 18 is -9, plus 4 is -5. Okay, so what does that tell us? Well, it tells us x was 3, and when x was 3, y was -5. So that tells us right now that 3, -5. X is 3, y is -5. That is your vertex. Okay, so I'm going to go find 3, -5. And we'll plot it. Okay. Now, if that's my vertex, then we're also going to have that line right there being the axis of symmetry. The axis of symmetry is the line x equals 3. Is that okay with everybody? Now, and I just want to demonstrate this algebraically, but it's really easy after you see this one time how to do this. I want to find more points because we know just one point is not enough to graph anything. So I need another point. So what I'm going to do is, if my axis of symmetry is not the y-axis, then my graph will intersect the y-axis somewhere else other than the vertex. So the y-axis is when x is 0, correct? So if I come over here and I take my original function, which was y equals x squared minus 6x plus 4, and I plug in x to be 0, if x is 0, what does this become? What's 0 squared? What's 0 times 0? 0. If x is 0 here, what's negative 6 times 0? 0. So it gives me minus 0, and then I got plus 4. Well, if x was 0, what does this all turn into? Just 4, right? And that will always be the case. If we go back up to what line 3 here was saying, it says now substitute x equals 0 into the function. It says this will always lead to y equals c. That's your y-intercept. So as long as there is a c value here, that is, well, no matter what, that's always the case. Even if that was 0, that is still going to be the y-intercept. Now it's just, if it is 0, then that's the probably the vertex as well. So, but whatever your c term is, okay, is where your graph is going to cross the y-axis, and that is every single function ever. Remember these? Remember y equals like 2x plus 3? I graph a line. What did this 3 tell me? It's where it was my y-intercept, right? Where we cross the y-axis. So no matter what the function is, x squared, x to the third, x to the fourth, whatever that c term is your y-intercept. Okay? The non-variable, c is non-variable. There's no x with it. That is always your y-intercept. So x is 0, y is 4. Okay, that's my y-intercept. With those 2 points in my line of symmetry, we should be able to realize that that distance right there is how many units? How long is that blue distance? 3. So when I use my line of symmetry and I fold on that line of symmetry, those 3 units should copy over there, right? And that should copy to a point right there, which is now going to be 6, 4, which now allows me with those 3 points, that's enough to graph this parabola. Okay? Now there will eventually, okay, when this is concave up, does this graph cross my x-axis? There's eventually going to be a procedure, which we've already done a bulk of it with factoring, but there's a procedure that is actually going to allow me to find that location and that location too. Those are your x-intercepts. And we'll find those in a couple sections. Those are all things that are important to a parabola: the vertex, the y-intercept, the axis of symmetry, and then ultimately the x-intercepts. If we have those, we can find those, we should always be able to graph it. And once we can graph it, we can then start using that for real life applications. Is that okay? Can we do that? All right, well, let's try it. Try it on that one. I'll give you guys about 5-6 minutes to do that. See what you come up with. So A is 3, B is 6, C is 2, right? I'm just going to start you off with helping to find X. X is the opposite of B over 2A. So opposite of 6 is negative 6 over 2A. Which would be 2 times 3, which is negative 6 over 6, right? So what's X become? X was negative 1. Once you know X is negative 1, plug that back into 3x squared plus 6x plus 2. So once you plug negative 1 in here, and you start evaluating, so negative 1 squared is 1, times 3 is 3. Okay, negative 1 times 6 is negative 6, and then plus 2. So that's going to give you y equals negative 1. So if x is negative 1 and y is negative 1, that's where your vertex is. Negative 1, negative 1. Okay, so now if that's where my vertex is, that is also where our axis of symmetry is. Okay. Now finding my y-intercept, remember above, now you could do the, you could put 0 in for x and do the evaluation, but what's going to happen is that everything cancels out and leaves you just y equals your c term, which in this case is y equals 2, right? So that's your y-intercept, where y is 2. So x is 0, y is 2. That's your y-intercept. So if that's my y-intercept, what is the point on the other side of my line of symmetry here that I need to graph? Negative 2, 2. And once you have that, and I'm terrible at this, but you then use a smooth curve the best you can to intersect those things. I like, and obviously you guys don't have it right now, I like using the computer because I can just kind of demonstrate that with the computer real quick. We can say, negative 1, we can type that in and it locates it. We can type in, we said our axis of symmetry was x equals negative 1, puts that in there for us. We can say that our y-intercept was 0, 2, puts that in. We said we should also have the point negative 2, 2, puts that in. So that's exactly what we did by hand, right? And then if I actually type in y equals, what was the equation? 3x squared plus 6x plus 2, does that put that graph through all three of those points? Okay, so obviously doing it by hand, I get that you're not going to be all that accurate with your parabola and graphing. But as long as you got those 3 points, so if we were doing a test by paper and pencil, I'm not judging you how well you're graphing this curve here. So you might, it might be real squiggly, right? I'm not judging that. I'm judging, do you have that critical point, that one, and the axis of symmetry right? If you got those points right, then my assumption is the graph is just the rest of it being wrong or maybe not as accurate is just human error. Okay, which some of us have more of that than others, right, Austin?
Yeah, I got the whole problem.
You can't divide and get 0 unless you start with 0, but you can't divide it by 0.
All right, great lesson.
We've got one more.
I put it away. On the day.
You're calling it a day?
Oh, disrespect.
I'll tell you what, we'll stop there. But tomorrow we're going to finish all of this.
Somehow Noah gets his way.
He doesn't get his way. He just realized we're on the.
Yeah, he's just